All right, we're back. Let's point out, made a few little changes here. Um, I changed my data step to just return week. We're just outputting the return week. I really didn't need to output to two different data sets, but it's a nice little technique to know. If you want to split data files up, you can output certain data one way and other data another way, which a lot of times works better than merging and filters. Anyway, um, so we're going to go from here and we're going to work on our first set of test statistics. So if I look at our paper, um, the first set of statistics under Theorem 1 is where we're using non-overlapping results. In other words, we're going to compare 1 week to 2 weeks, but the 2 weeks don't overlap. So what we want to do right now is go ahead and get this set up so that we can calculate our sums. Notice that each one of these guys represents different sums as we go through the underlying data set, along with some error checks for things to work out correctly. Ultimately, we want to get this JD and JR statistics and then use the asymptotic distribution properties to test whether we are reject the null hypothesis or fail to reject the null. All right. So hopefully what you've understood here is that we've got to sum these guys up 2 weeks, like week 1 and week 2, we're going to add together, and then we're going to do 3 and 4. We're not going to add 1 and 2 and then 3 to 4. That's this first part. The second part, the second theory in theorem under 2 for the M statistic is where we're actually using overlapping periods. So in that case, we're going to do 1 plus 2, then 2 plus 3, then 3 plus 4. And that changes the underlying distributional properties because now we're introducing serial correlation. But asymptotically, it's better because we need less data to create more observations. All right, so back into SAS. So we'll start with just again, these brief little comments that you put in here. They're for you. Don't worry about spelling or anything else. They just need to be there to jog your memory and to let other people kind of know what's going on. So here's the data form. All right, so this is what our data step is actually going to end up doing. We're going to use our little mod function again. I'm just calling it start ag. You can call it anything you want. We're going to go ahead and set our RTRN week. So this is our return data that we're going to be using. And we want to put a counter in there. All right, so what I want to create, and let me just go ahead and let me put 2 of them in here, and then I'll run the data step and show you what it actually looks like. So we want to do all right, I'm going to go ahead and run this. So if we look at a table that's in LoMac, you'll see that they're using Q of 2, 4, 8, and 16. And we need to have equal numbers associated with it for the distributional properties. And then we'll compare week 1, the variance of 1 week should be 2 times the variance of 2 weeks, and 4 times the variance of 4 weeks, and 8 times the variance of 8 weeks. That's the nature of the underlying tests. So this is what we're going to attempt to incorporate in the overall analysis. And then let's look at what the data step looks like. So I'm just going to go ahead and run this data step real quick. Check, make sure that I didn't have any observation issues. And go ahead and clear everything. And then we're going to look at our start aggregation. So you see here we got 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So we're setting up our weeks in pairs. And this becomes the 4-week group, right? So these are all the 1s, these are all the 2s, these are all the 3s, 4s and 5s, etc. And that's going to allow us to use proc means, and then we'll do a sum by, and then we'll list our N2 variable, N4 variable, etc. And that way we'll get 4 weeks summed together for N4s, and we'll get 8 weeks summed together for N8s. So that is the objective that we're looking for, and it's just a direct application of what is actually in the paper. And this is exactly what they're telling you to do. So here's my underscore n underscore again, and then I want 8 equals 1, then n8 plus 1, and this is just shorthand code to get things to increment. I could do an n2 equals n2 plus 1, but this is just shorthand to get it done. And then our last one, and that's going to be 16 equals 1, and 16 plus 1. All right, so we've got all of our variables now set up. I'm going to go ahead and just run it again to show you what it looks like. And then we'll take a look at our start ag. So here's our group of 16, here's our group of 8, group of 4, and then finally our groups of 2. And then of course we always have our base unit week, 1 week at a time, every 5 day. We've defined a week as 5 days, which is the best we can do with the data is now available. We can actually not reproduce this paper unless we can get the original crisp data discs from, I don't know, maybe 2004, I think is when they started to adjust everything. All right, so that's our data steps. So now we want to do what it says in the paper. So if we look at our paper, it says that we just want to start summing things up based on our NQ positions, okay? So we need to sum up for our means. So we're going to use a proc means tab, proc means, no print. So that means we're not going to send any data to the output. The data that I'm going to use is my STRT aggregation setup. The var is going to be my week RTRN. We're going to do by N2, and then we're going to do an output. Out equals temp2, sum equals sum2. All right, so this is gonna this is proc means. No print means we're not gonna put any output for it. Makes things run quicker and just keeps things nice and clean. It's gonna use the data step start ag. The variable we're interested in is our week return. So that's this one here. And then we're gonna do it by N2. So we're just gonna sum these guys out. That's for every 2 week periods. So that's our first step that we're interested in. We're going to go ahead and do a control C, always interested in efficiency, control V. In this case, we're going to sum by N4, and then we're going to call the output sum4. And our temp becomes temp4. Now, I get this every once in a while. It's not like I'm sitting here and I am just off the top of my head looking at this paper and suddenly generating all the code that I need to generate to instantly test it. All right. Off to my side here, I have preset code that I've written when I actually applied this paper for research back in my youth when I was a PhD student. So don't get the idea that you just sit down and start banging this stuff out like it's nothing. It takes a lot of work. It takes a lot of thinking. And you got to be very familiar with the different issues associated with SAS. So we got one more guy that we need to do here. I'll do a Control C, Control V, and then now we're going to go to our 16. All right, I'm going to call it some 16. And then that's going to be the output that we're interested in. So we're marking everything for each underlying week. A lot of times, again, I'll dump and run in here. Rather than run this all as one big group, let's just go ahead and run a quick subset of it. All right, so we've got our output. Our output is temp2. We'll double click on that, and here's N2s 1, 2, 3, 4, 5, 6, 7, 8, etc. And this represents the sum of the 2 weeks added together. And you'll notice that we have a frequency here of 2. All right, I'm going to exit out of that. Now we can get rid of this run. And you can put proc statements inside of a data set, or you can put proc statements outside of this data set. Another point I want to make. If I call proc means no print and define the data set for it, and then create a new data set, in this case it's temp2, the SAS pointer is at this new file that's been created. So if after that I do a proc means and don't specify a data set. So let's say I just do it that way, and the var is my RTRN, and then I do it by and for, and then this output statement, dot, 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 doesn't matter. I'm not going to run it. But if I then try and run this, it is going to try and do this proc means on temp2, which is not what I want. I want to always go back to the original data step. So be aware of that. It's always better to explicitly say what data step I want the proc to occur on. And then if a proc is inside a data step like it is in this case, once the proc is called, you cannot change the data set anymore. So the way this is going to work is it's going to set return week. It's going to do all these calculations. It's going to go all the way through the data step and do that. And then it's going to come back and run the different procedures that I'm asking it to run. I'm going to go ahead and save the file. And we'll go ahead and run the whole group. So here's my temp16. Okay. You notice that my frequency here is 16. Now, we have X number of weeks. I do not know for a fact that 16 divides into the number of weeks that we have. So I'm going to yank down here real quick at the bottom. You can see at the end I have a week of 4. That's a problem. Right? We can't use this variable in the analysis because it's not a consistent whole number associated with it. All right, so now we want to do some error checking. So I'm going to go to data temp2. I'm going to set temp2. And I'm going to say if underscore FEQ frequency equals 2. All right. So what this is going to do is if there was an odd number of weeks, for example, then the last one may only have 1 week associated with it. So I need to get it out of there. And then again, we have data temp4. We'll set temp4. And then if underscore req underscore is equal to 4. Right? So in this case, we're dropping if it's a 3 or a 2, it goes out. Data temp 8, and then again, most of the work in research is actually getting the data in the right setup. In other words, configuring it correctly for any kind of testing or analysis. So going through here and taking the time to really understand how the computer and your code allows you to check for errors can become really helpful. All right, I got one more here to do. Data temp 16. And then we want to set temp 16. And then if underscore FREQ underscore equals 16. Now, I also get a lot of times people say, well, there's only one number in there. You just saw it, so why don't you just go and delete the last observation? That's fine and dandy, but I'm writing this code in order to test the underlying method of LoMac so that my numbers should be really close to what theirs are. And then I might want to apply it to some period in the future where, again, I don't know how many weeks are actually going to be represented in the underlying data set. So like one of the issues that you might want to critique actually of McKinley is the fact that they use calendar weeks, right? Where really this test should be over 5 consecutive days, not over calendar weeks, right? So some of their calendar weeks have only 4 days in it. Some calendar weeks only have 2 days because of where certain holidays fall on the whole group, where you'll get a Christmas Eve off, a Christmas Day off, and then the market's only open a half a day on other aspects of it. And they called that a week. So the underlying theory should actually be every 5 days. So anyway, I don't know in the future whether I'm going to have 5 days or not. Or let me rephrase it, how many weeks. By writing the code this way, we get to blow through, and it doesn't matter what time frame I throw at this program now, it is always going to do the only rounded analysis days. All right. So I've gone through all my filter sets, and let's go ahead and run this and make sure that there's no errors. So I'm going to highlight and run, and then always go back to my log and make sure that there's no things that just kind of look like they have an underlying problem. So that's 586 days of 2s, and 293 weeks, and 147, and finally 74 of the 16 variables. And then there's only 73 after we've dropped this other number. All right, so here are all my variables. I've got everybody summed up together. Now we want to go ahead and look at merging the data for my temp2, temp4, temp8, and temp16 to create a single merge set. Excuse me. And then your variable, the names that you're using here are up to you. Generally, if I was doing more serious research code, in this case, my data step definitions are going to be a little bit more accurate, let's say. and more intuitive. In other words, instead of being merge one, it might be weekly summed returns. I don't know. My point being is that when you're doing any kind of naming, throwing temps in there is usually not necessarily a good idea, because when you come back to it, it makes it difficult to follow. So I'm just going to merge temp 2, temp 4, temp 8, and temp 16. And it's, you know, it's also possible that you can run the test individually. We always want to keep our data sets clean, so we're going to drop type, and we're also going to drop our FREQ. We don't need those guys anymore in our analysis, so there's no reason to keep them in. So let's go ahead and run this guy. So now I have my merge 1, which has our N2, N4, N8, N16, and then the underlying sums with sum 2, sum 4, sum 8, and sum 16. So that everything's following kind of in a logical net position. Last thing I want to do is go ahead and create a analysis data set. This is the one that we're going to actually do most of our work with. So I'm going to do a data and then my dat, and then I'm going to call it start ag. Alright, so this is actually going to save it off. And then my merge 1. So I'll put a little comment here, save off data. Alright. So in this case, let me just go ahead and run the little step. So when I've done this, it's gone off and done the saving. Let me come over here. So this is now my date, and this is where that data set actually is. So the data set has been saved off to this file on my jump drive, actually, not my hard drive. So at this point, if I wanted to, I could go ahead and save my file and then exit out, and then when I come back into the video, I could then create, so and then I'm going to set alright, so that's going to bring all the work that I've done back into a work file, and we can then, you know, email the underlying data set for other people to work on, do all kinds of other things associated with it. Okay, so first video ran a little longer. You guys are PhD students, so if I'm doing undergraduates, I try and keep them to around 10 minutes. Here I'm going to do it in such a way that we have good underlying stopping points to then get our work done. So I'm going to go ahead and stop the video here. I want you guys to take some time and go back without watching the next video yet, but go back and look at the code and make sure that you're understanding what it's doing and why it's doing everything. So that you understand this and what we're working towards in terms of creating this the analysis and how to do your coding, right? How to read the material that's in a paper and convert that into an actual program that you can then use as analysis. All right, so we have our proc means, no prints. Anytime you call proc means, you're always going to get out this underscore type, underscore frequency. You can actually come in here and do a drop underscore type underscore FREQ. All right, and that's going to drop these two guys out when it does the analysis. Of course, we're using frequency to make sure that everything tallies up, so that we do not want to include that in there. All right, so this is where I'm going to end step 2. When I come back, what we're going to do is calculate the underlying statistics, and then we're going to use proc export to export this stuff into Excel, and then we're going to build a table in Excel. And then after that, we're going to come back and work on the overlapping analysis. All right, thank you very much, and save this guy off. And hopefully you guys are enjoying the process of learning how to code and getting an idea of where the logic is that you use to do your analytical studies. All right, thanks a lot. Bye.